Okay, let's tackle 13.4A5 now. Again, trying to choose looks like one of the trickier ones because if you can do A5, you should be able to do all the other ones. So A5 says to basically you want to graph this thing here. Okay, and they kind of help you out by by showing you this formula in the beginning and everything. So I'll talk about that. But okay, so let's graph this thing. So absolute values, first you got to know what the function looks like. This is the absolute value function. So the absolute value function looks, okay, so the absolute value of x, this is the absolute value of x, and it looks like this, right? It looks like x, except it never goes negative. It looks like this v, 45 degrees, goes on forever, up and down, right, but never goes negative. Y equals x, but doesn't go negative. So we're going to take that function and do a bunch of stuff to it, and then we know what the original function looks like. So we're going to shift it and dilate it and compress it and all that kind of stuff. So, and the order really matters. If you do it in the wrong order, it'll look totally different. So you got to do it in the right order. So the first step is you got to get the x by itself, like we talked about before. 2x minus 1, no, that doesn't work because here's our function here. So the first step is we do our f of x. It'd be 3 times 2 times x, again minus 1/2, plus 5. And check that, 2x gives us 2x, 2 times negative 1/2 gives us negative 1. So yep, that looks right. Okay, now we are in a place to say what we're doing. Now they say write it in the form a times b x minus c plus d, which we did. Okay, so you don't need to write this out. All they're saying is write it in that form. They're just basically reminding you to get the x by itself. So our b is 2, our a is 3. Okay, whatever. The b tells you how much to dilate it in the x direction. Okay, by 2. The 1/2 says how much to shift it. The d says how much to shift in the y direction. And the a tells how much to dilate in the y direction. So it's kind of nice here. And the order we always do those, I'll write the order here first. We always dilate first, so first you do b, then you shift in the x direction. You always do the x's first, starting with dilations. Then you do c, and then you do a, and then you do d. Now we don't have any negatives here. It's not a negative x or a negative 3. If it was, you do that. If we had a negative, we would do that after. It's the last x thing we'd do is we would reflect it, make x into negative x. So that would be after c. That would be the last thing we do. But we don't have that. And if we had a negative a here, we'd do that after we dilated it, before we did d. But we don't have a reflection here, which is unfortunate. But you would do that right after you dilated it, and then the last thing you do is you add d. That's the last step. Okay, so what are our order of operations here? So B, C, A, D. So first, the x direction, we compress it by 2. That's our first step. In other words, multiply it by 2 is always the opposite. Make it smaller by 2, or multiply your x coordinate by 1/2. Whichever one you like again. Okay, then we shift it to the right by 1/2 because it's negative, and we always do the opposite. If you take away from the x, you're shifting it to the right, making it more positive. Then we're compressing it in the x direction, in the y direction by 3, and now that means you actually make it 3 times bigger. So in the y direction, we actually are dilating it, we're making it bigger by 3. Y direction makes sense. If it's 3 times bigger, it's 3 times bigger. So 3 times dilated. And then finally, we're adding 5, so we're shifting it up 5 in the y direction. Again, the y direction makes sense. If you're adding 5 to y, you're raising it up by 5. Okay, let's see what that would look like now. The vertex is one point that we can actually shift easily, and we need another point on here. So let's put some points in our graph that we can actually shift so we know how to do our final ones. So this one, of course, is 0, 0. It always starts there. Here is negative 1, 1. We just choose the easiest ones possible. This is 1, comma 1. Okay, so negative 1, 1. What's going to happen to that? 0, 0, our vertex, what's going to happen to the vertex, and 1, comma 1, what's going to happen to that one. And if we know what happens to those three, we can draw the new graph. We just connect the dots from the vertex up to those points. Okay, so shrink it in x direction by 2 or multiply the x by 1/2. Okay, this is the same thing as times 1/2. So that would be negative 1/2 comma 1, y stays the same. Multiply x by 1/2, 0 times 1/2 is still 0. X by 1/2, so that becomes 1/2 comma 1. Now shift it to the right 1/2, add 1/2 to the x. That's 0 comma 1, add 1/2, 1/2 comma 0, add 1/2, 1 comma 1. Again, y stay the same. Check that. Made a mistake in the last problem. Yep, that looks right. Now we got to this point. Now we multiply the y by 3. Multiply the y by 3. So this becomes 0 comma 3. This becomes, again, the x's stay the same. 0 times 3 is still 0. 1 comma 3. Multiply the y by 3. Yep, that's right. Now add 5 to the y, so 0 comma 8, 1/2 comma 5, 1 comma 8. So those are our new points. So to graph this, we would go like this, 0 comma 8, let's see, I'm going to make 8 right here, so there's comma 8. 0 comma 8, 1/2 comma 5. Okay, if this is 8, this would be 4. That'd be 8. So this would be 4. This would be 2. Boy, 1/2 is like right there. So 1/2 and then y equals 5 would be like right there. That's the vertex now. And then 1 comma 8. 1 would be right there. Okay, this is why I should have made my x-axis more spread out. Oh well, 1 is, there's 2, so 1 is like right there, 1 comma 8, so it looks like this. It's skinnier, and because it's skinnier because we compressed it, right? We made it 2 times skinnier here, and then we stretched it out, we stretched it upwards. So it's practically like 6 times skinnier. So it is, we can see it's pretty skinny here. My graph is not to scale. If I did this again, I'd make my x-axis bigger or something, but whatever. So it would look like that. And the vertex we know is going to be 0 comma 8. That's one thing they want you to figure out is the vertex, because that's a good point to know. Okay, now let's do part B. Let's see. Yes, let's do B3 now, because we're going to take what we just did, B3, and they say solve these inequalities. So we want, is that this one? Yes. So we want that y equals 3, 2x minus 1 plus 5. We want to know when that's greater than or equal to 10. So that's the thing we just have, right? They're using E here, A5. They're using A5, the same function we had, and they want to know when is that greater than or equal to 10. Now, if we had a good graph, okay, when is that greater than or equal to 10? Well, this is 8. So 10 is somewhere up here. Again, I have a bad, oops, sorry, there you go. I have a bad graph, but there's 8. So when is it greater than or equal to 10? Well, it's greater than or equal to 10. Chop it off right here, from right here, and right here up to infinity, right? For all the way up to there, all the way up to there. So from this point to that point, it's greater than or equal to 10. Okay, so how do we figure out where that is now? So there are and they say, using your work in the previous part of this problem. Okay, and by the way, we did not do the multi-part rule. We did not do the multi-part rule here, and that's what would really help us. So let's do that. I forgot to do that for A5. So the multi-part rule. The vertex is an important point. It's at, did I mess this up? The vertex is at, no, it's at 1/2 comma 5, right? There's our vertex. 1/2 comma 5. Yep, that's right. So when x is greater than 5, sorry, when x is greater than 1/2, we have the line going up this way. When x is less than 1/2, we have the other line. So we know that's the switchover point. So our multi-part function is two parts, for x greater than, or we could say equal to 1/2, and for x less than or equal to 1/2, because that's the vertex, that's where it switches over from going this way to that way, right? That's the sharp point. So that's the nice thing about figuring out the vertex. We don't have to solve for when this thing is equal, when 2x minus 1 is equal to 0, though that would be hard. We can see that at 1/2, that's where it switches over. 1/2, 2 times 1/2 is 1, minus 0 is 0. But we know that from our graph. Okay, so when x is greater than or equal to 1/2, then we don't need, that's this part, we don't need the absolute values. What's inside is always positive. So it would be 3 times 2x minus 1 plus 5, which we could solve that a little bit easier. That would be 6x minus 3 plus 5, which is 6x plus 2. Okay, so it's 6x plus 2. Now when x is less than or equal to -1/2, then we make what's in the parentheses negative. So it's 3 times negative of 2x minus 1 plus 5, which is 3 times negative 2x is negative 6x. Negative 1 is plus 1, so plus 3 plus 5. Or, and I'm running out of room, negative 6x plus 8. Negative 6x plus 8. So that is our multi-part function, 6x plus 2 and negative 6x plus 8. So when are those greater than or equal to 10? So we now, so now we just say when are those greater than or equal to 10? So the first one is when is 6x plus 2 greater than or equal to 10, or basically equal to 10. So let's see. So what, 6x would be, and I'm going to set equal, then we know it's greater than. I'll just use it like this. So greater than or equal to 10 minus 2, or 6x greater than or equal to 8, or x greater than or equal to 8/6, which is the same as 4/3. So that's the case when x is greater than or equal to 4/3. Now let's do the other one. Negative 6x plus 8 greater than or equal to 10. That's negative 6x, subtract 8 from both sides, greater than or equal to 2x. Okay, when you divide by negative 6, that means you switch the greater than or equal to less than or equal. That's the thing. If you multiply or divide by a negative number, that's when you switch the signs. So I got to switch the sign because I'm dividing by negative 6 is less than or equal to 2 over negative 6, which is negative 1/3. So when is this greater than or equal to 10? When x is greater than 4/3, should be a 4/3 there, or x is less than negative or equal to negative 1/3. Okay, a lot of work here. These problems are a lot of writing. Fortunately, you have time to do it. It really helps to write it all out, draw the graph, redraw it if you want, because obviously mine's not so good. It really helps you to see the graph. And then part B is in using these things here to help you solve some inequalities. Okay, hope that helps. Let me know if you have any questions.